the next topic we are going to discuss is non-homogeneous system of linear equations. Non-homogeneous system of linear equations. We will discuss in what situations a solution of non-homogeneous system of equations exists and in what situations it does not exist. And if the solution exists, we will discuss how to find that solution. Now consider a system of non-homogeneous equations. Say this: a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z equal to d3. Now this system of equations can in short be written as ax equal to b. Ax equal to b, where A is the coefficient matrix. A is the coefficient matrix. That is, write the coefficients of x in the first column. Coefficients of x are a1, a2, a3. a1, a2, a3. Coefficients of y are b1, b2, b3. b1, b2, b3. And coefficients of z are c1, c2, c3. c1, c2, c3. So this is the coefficient matrix. And x is the variable matrix. x, y, z. These are three variables: x, y, z. And this is the constant matrix: d1, d2, d3. Now ax equal to b. Now multiply a with x. What we do is multiply the first row with all the columns. There is only one column, so only one column will be multiplied with the first row. So multiply this row with this column. We will get a1x plus b1y plus c1z. a1x plus b1y plus c1z, and first entry here is d1. So this must be equal to d1. We will get the first equation. And similarly multiply this with this. a2x plus b2y plus c2z will be equal to d2, the second entry. And a3x plus b3y plus c3z is equal to d3. So this system of equations can in short be written as ax equal to b. Now we discuss the solution of system of non-homogeneous linear equations. We discuss in what situations will the solution of this system of equations exist and in what situations it does not exist. That is, in what situations this system of linear equations is consistent and in which situations this is not consistent. What we do is we first find determinant of A. Now if determinant of A is not equal to 0, then this system of linear equations will have a unique solution. If determinant of A is not equal to 0, then it will have a unique solution. But if determinant of A is 0, then this system of equations either has no solution or infinitely many solutions. The possibility of unique solution will not exist. The system will either have infinitely many solutions or no solution. Therefore, we find determinant of A if it comes out to be non-zero. Then the system will have a unique solution, and that solution is given by x equal to A inverse B. X equal to A inverse into B. We will find A inverse and multiply it with B to get the solution. Now if determinant of A is 0, what we do is we find adjoint of A into B. If adjoint of A into B is 0, then the system will have infinitely many solutions. And if adjoint of A into B is not equal to 0, then the system will have no solution. In this case, what we do is put z equal to k. Put z equal to k. Now we have only two variables and three equations. Solve any two of these three equations to get x and y. And this solution will be the required solution. X and Y will be in terms of K, and K can have any value, 1, 2, 3, 0.5, 0.2, 0.3, 3 by 2, K can have any value, and therefore there will be an infinitely many solutions. Now we take up some problems based on this. Now first problem is solve the following system of equations by matrix inverse method. Now we are given a system of equations, this system of equations can be written as Ax equal to B, where A is the coefficient matrix. Now coefficients of X, these are 5, 7. Coefficients of Y, 2, 3. And X is X, Y. We have only two variables. And B is equal to 4, 5. 4, 5. Now first of all, what we do is we find the determinant of A. Determinant of A is equal to 5 into 3, 15, minus 7 into 2, 14. That is 1, which is not equal to 0. Therefore, system has a unique solution. Therefore, system has a unique solution. And we find A inverse. To find A inverse. Now, what we do is cofactors of R1. We first find cofactors of R1. Cofactors of R1. Delete the row and column in which the entry occurs. Now place of this entry is 1, 1. So we will have a plus. This is gone, we get 3. So 3. And cofactor of the next entry. This is deleted, this is deleted, this is 7. And place of this entry is odd. 1, 2. So there will be a negative sign. And similarly, cofactors of R2. Second row. Now delete the row and column in which the entry occurs. This is gone, this is gone. We get 2. And place of this entry is odd. So we will have minus 2. Now place of this entry is 2, 2, which is even. So we will have a plus sign. Delete the row and column in which the entry occurs. We will have 5. Therefore, adjoint of A is equal to. Replace each entry by its cofactor and take the transpose. Now replace each entry by its cofactor. 3 minus 7 minus 2, 5. And take the transpose. This is equal to, now this will be 3 minus 7. Transpose is interchange the rows and column. 3 minus 7 will become the first column. This row will become second column. Minus 2, 5. This is adjoint of A. A shortcut for finding adjoint of A is interchange the diagonal entries. Interchange the diagonal entries. This will become 3 and this will become 5. And take negative sign with the remaining. So interchange these two, 3, 5, and take negative sign with this. Minus 7 minus 2. You can directly write adjoint of A is equal to 3 minus 2 minus 7, 5. Interchange the diagonal entries and attach negative sign with the remaining. For 2 cross 2 matrices, this shortcut is there. So A inverse is equal to adjoint of A over determinant of A. And determinant of A is 1. So adjoint of A or determinant of A will be equal to this much only. 3 minus 2 minus 7 and 5. This is A inverse. Therefore solution is X is equal to A inverse B. A inverse B. And this is equal to, how much is A inverse? A inverse is 3 minus 2 and minus 7, 5. And B is, how much is B? B is 4, 5. So this is equal to this into this. 3 4s are 12, 12 minus 10. 12 minus 10 is 2. This into this. Minus 28 plus 25. Minus 3. And X is XY. Therefore we have XY is equal to 2 minus 3. This implies X is equal to 2 and Y is equal to minus 3 answer. You can check it by substituting in any one of the equations. X equal to 2. This will be 10. 10 minus 6. That is 4. 4 equal to 4. This equation is satisfied. And similarly, this will also be satisfied. But as a precaution, you can check the solution by substituting in one of the equations. Now next question is, solve the following system of equations by matrix inverse method. Now we are given this system of equations and we have to find the solution. Now this system of equations can in short be written as Ax equal to B, where A is equal to the coefficient matrix. Coefficient matrix. Write the coefficients of X. 1, 2, 1. 1, 2, 1. Now write the coefficients of Y. Minus 1, 1, minus 2. Minus 1, 1 and minus 2. Write the coefficients of Z. 1 minus 1 minus 1. 1 minus 1 minus 1. This is A. X is the variables. X, Y, Z. These are the three variables. And B is 1, 2, 4. Now first step is we find determinant of A. Now determinant of A is equal to determinant of 1 minus 1, 1, 2, 1 minus 1, 1 minus 2 minus 1. Now first step is we find determinant of A. That is determinant of this matrix. And this is equal to 1 expand by this row. This is gone, this is gone. We have 1 into. Now delete this, delete this. This into this minus this into this. So minus 1, minus minus plus, and there is one more minus. So negative sign will be there. So minus 1 minus 2. This will be minus 1 minus 2. And we take alternate plus. This is plus, this will be minus. So minus minus plus 1. Now delete the row and column in which the entry occurs. This is gone, this is gone. Minus 2 minus minus plus 1. Minus 2 plus 1. And next is this. So we will have alternate plus minus, plus minus plus. So 1 into, now this is gone, this is gone. 2 into minus 2 is minus 4 minus 1. Minus 4 minus 1. So this is equal to minus 3 minus 1 minus 5. This is equal to minus 9. So determinant is minus 9 and which is not equal to 0. Therefore, the system has a unique solution. And that solution is given by x equal to A inverse B. Now to find A inverse, we find the cofactors of first row. Now cofactors of first row. This is positive, plus, minus, plus. First is delete the row and column in which the entry occurs. This is gone, this is gone. This will be 1 into minus 1, minus 2 into minus 1. So this will be minus 1 minus 2. Minus 1 minus 2. Minus 1 minus 2. And next will be, this is gone, this is gone. Minus 2 plus 1. And next will be, this is gone, this is gone. Minus 4 minus 1. Minus 4 minus 1. So this is equal to minus 3 plus 1, and this will be minus 5. Now we find the cofactors of the next row, that is R2. Now to find the cofactors of R2, now place of this entry is, this is second row, first column, odd. So this will be minus. Minus, next will be plus, and next will again be minus. So cofactors of R2. Now this is an odd place entry, so this is gone, this is gone. These two are gone. Minus 1 into minus 1 is plus 1, minus minus plus 2. So 1 plus 2. This will be 1 plus 2. Next, this is gone, this is gone. 1 into minus 1 is minus 1, minus 1. Minus 1, minus 1. Next is, this is gone, this is gone. Minus 2 plus 1. Minus 2 plus 1. That is, this is minus 3 minus 2, and this is plus 1. Now we find the cofactors of R3. Cofactors of R3. So first entry is this. This is 1, 2, 3. Third row and first column. 3 plus 1 is 4. So this will be plus. Now delete the row and column in which the entry occurs. This column and this row. So we are left with minus 1 into minus 1 is 1 minus 1. 1 minus 1 is 0. Next cofactor will be negative. Now delete the row and column in which this entry occurs. That is, this is gone, this is gone. So minus 1 minus 2. Minus 1 minus 2 is minus 3. And third is, now this entry. This column is deleted, this row is deleted. Delete the row and column in which the entry occurs. So this will be 1 minus minus plus 2. 1 plus 2 is 3. So these are the cofactors of R1, R2 and R3. Now we find adjoint of A. Adjoint of A will be obtained by replacing each and every entry of A by its cofactor. We will get the matrix minus 3, 1, minus 5, minus 3, minus 2, 1, 0, 3 and 3, and take the transpose. You can see the last sheet on the side. So first row of adjoint of A will be minus 3, 1, minus 5. Second row will be minus 3, minus 2 and 1. Minus 3, minus 2 and 1. And third row will be 0, 3, 3. 0, 3, 3. And take the transpose. This is equal to, this row will become the first column. So this will be minus 3, 1, minus 5. 1, minus 5. This will become the second column. Minus 3, minus 2, 1. Minus 3, minus 2, 1. And this will become the third column. So this will be 0, 3, 3. This is adjoint of A. And therefore A inverse is equal to adjoint of A over determinant of A. Adjoint of A over determinant of A. That is adjoint of A over. How much is determinant of A? Determinant of A is minus 9. So this is equal to minus 1 by 9. I will keep minus 1 by 9 outside. This will simplify the calculations. This is equal to minus 1 by 9 into adjoint of A, which is this. And therefore solution is x equal to A inverse B. Now A inverse is minus 1 by 9 into this. And B is 1 to 4. Multiply this, we will have minus 1 by 9 into. Now this into this. Minus 3, minus 3, minus 6 and 0. This into this. 1 minus 4 and 12. 1 minus 4 plus 12. This into this. Minus 5, 2 and 12. Minus 5, 2 and 12. Simplify this. Minus 1 by 9 into. This is minus 9. 13 minus 4 is 9. And this will be minus 3 and this will be 9. Therefore, x is x, y, z. So this is equal to 1. Divide each and every entry by minus 9. So this will be 1, this will be minus 1 and this will be 1. Therefore, x is equal to 1, y is equal to minus 1 and z is equal to minus 1 answer. You can check it by substituting in any one of the three equations as a precaution. So first equation is x minus y plus z is equal to 1. Now substitute in this. X is 1. This is minus 1. So this is plus 1. And z is minus 1. This is minus 1 equal to 1. Satisfied. 1 equal to 1. Therefore this is the correct solution. Now the next question is, we have to solve this system of equations. Now these equations are not directly in terms of x, y and z. They are in terms of 1 by x, 1 by y, 1 by z. So we first solve this system of equations for 1 by x, 1 by y, 1 by z. And then take the reciprocals to get x, y, z. So here what we do is, we will take the variable matrix as 1 by x, 1 by y and 1 by z. And so the coefficient matrix A will be equal to, now coefficients of 1 by x are 2, 1, 3. So 2, 1, 3. Coefficients of 1 by y are minus 3, 1 and minus 1. Minus 3, 1 and minus 1. And quotients of 1 by z are 3, 1, 2. 3, 1, 2. And the constant matrix B is equal to 10, 10 and 13. So we will solve this system of equations for 1 by x, 1 by y and 1 by z, and then take the reciprocals to get x, y, z. So first we find the determinant of A. Now determinant of A is equal to, now expand it by first row. This will be 2 into, now delete the row and column in which this entry occurs. 2, this 2 minus minus plus 1. 2 plus 1 is 3. Next is, this is plus, this will be minus. So minus minus plus 3 into, this is gone, this is gone. 2 minus 3. 2 minus 3 is minus 1. And next is 3 plus 3. Plus minus plus. Plus 3 into, this is gone, this is gone. Minus 1 minus 3 minus 4. And this is equal to, now 6 minus 3 is 3. 3 minus 12 is minus 9. So this is not equal to 0. Therefore, the given system has a unique solution. Therefore, now we find A inverse. Now, A inverse is equal to adjoint of A over determinant of A. And this is equal to, adjoint of A is replace each entry by its cofactor and take the transpose. So what we do is we first find the cofactors of all the rows, all the entries. Now cofactors of R1. This is the first entry. So this will be plus, next will be minus, and next will be plus. So first entry is this. Delete the row and column in which this entry occurs. So these two are gone. We are left with 2 minus minus plus 1. 2 plus 1 is 3. Next is this. So this is gone, this is gone. 2 minus 3. 2 minus 3 is minus 1. And next is this and this are gone. Minus 1 minus 3 minus 4. So we get 3, 1 and minus 4. 3, 1 minus 4. Now we find cofactors of R2. Cofactors of R2. So second row. Now place of this entry is 1, 2. Second row and first column. That is odd place. So we will have minus. So this will be minus, this will be plus, and this will again be minus. So now this entry. Delete this column and this row. So we are left with minus 6 minus minus plus 3. Minus 6 plus 3 is minus 3. Next is this. Delete the row and column in which the entry occurs. So 4 minus 9. 4 minus 9 is minus 5. And next is this. So delete the row and column. We get minus 2 minus minus plus 9. Minus 2 plus 9 is 7. Now we find cofactors of R3. Cofactors of R3. Now cofactors of R3. First entry is this. Now place of this entry is third row and first column even. So this will be plus, next will be minus, and next will be plus. There will be alternate plus minus signs. So delete the row and column in which the entry occurs. So delete this and this. So we are left with minus 3 minus 3, that is minus 6. Next is this, delete the row and column. 2 minus 3, 2 minus 3 is minus 1. Next is this, delete the row and column. 2 minus minus plus 3, 2 plus 3 is 5. So this is minus 6, 1 and 5. Therefore, adjoint of A is equal to. Replace each entry by its cofactor. So this entry will be replaced by 3, 1 minus 4. This will be minus minus plus 3. This will be minus 5 and this will be minus 7. And this minus 6, 1 and 5. And take the transpose. This is equal to now take the transpose. This row will become first column. 3, 1 minus 4. Second row will become second column. 3 minus 5 minus 7. 3 minus 5 minus 7. Third row will become third column. Minus 6, 1 and 5. And therefore A inverse is equal to adjoint of A over determinant of A. That is, determinant of A is minus 9. So this will be adjoint of A over minus 1 by 9 into adjoint of A. Adjoint of A is this. 3, 3 minus 6, 1 minus 5, 1 and minus 4 minus 7 and 5. And therefore X is equal to A inverse B. This is equal to minus 1 by 9. I will keep this 9 outside. This will make the calculations simple. So this will be 3, 3 minus 6, 1 minus 5 and 1 minus 4 minus 7 and 5. This into B. B is 10, 10, 30. And this is equal to minus 1 by 9 into, not this, into this. So this will be 30 plus 30, 60, 60 minus 78. 60 minus 78 will be minus 18. Now this will be 10 minus 50, minus 40, minus 40 plus 13 is minus 27. This into this, minus 40, this into this, minus 40, minus 70, minus 110 plus 65. Minus 110 plus 65 will be minus 45. This is minus 40, minus 70, minus 110 plus 65 is minus 45. And this is equal to, divide by minus 9. This will be 2, 3 and 5. Therefore, 1 by X, 1 by Y and 1 by Z is equal to. This is X and X is 1 by X, 1 by Y, 1 by Z. X is this much. X is this much. So X is this much. 2, 3 and 5. And therefore 1 by X is equal to 2, 1 by Y is equal to 3 and 1 by Z is equal to 5. And therefore X will be 1 by 2, Y will be 1 by 3 and Z will be 1 by 5. This is the answer. And you can check it by substituting in any one of these equations. For example, you put in first, so we will get X is 1 by 2. So this will be 4 minus Y is 1 by 3. 4 minus 9 and z is 1 by 5. 1 by 5, so this will be 15 plus 15. And on simplification, this is 10, which is equal to RHS. Therefore, equation is satisfied, and as a precaution, we have checked that our answer is correct.